just a quick introduction. So thank you very much for all of you all to actually come this morning and join us in this morning's session. All right, just a quick introduction on who we are. So I'm Kenneth, I'm with MSF Worldwide. So what we do is we mainly do a lot of events and exhibitions based overseas. But recently, you know, as we can't go overseas, so what we do is we go virtual. And hopefully at the end of the day, what we are sharing with you, hopefully it makes sense. And eventually, if it makes sense for you as well, time to go digital as well in a sustainable way. All right. So just some quick, oops, it's not, let's see now. All right, cool. So as you can see, so just a quick some ground rules for all of you. So of course, definitely please mute yourself. Please conduct yourself in a decent manner as well. So if you have any questions along the way, please switch on the video, unmute yourself, of course, definitely, and definitely introduce yourself, please, as well, so that you know where you're coming from and ask your question away. Please do ask some interesting questions so that the panel here, Dr. Chua and Gerard, can actually answer, because we learn from each other as well, most importantly. You know? So, this is the agenda today. All right. So what will happen is there's a quick welcome remark, which I will do currently. Then after that, we'll go on towards Dr. Chua, who will actually share the value of data, and Gerard from PNF, he will actually share with how the future is now. All right. Now, so a bit of who we are, like I mentioned earlier. So we are actually a sales partner for SHRDC, of which they own actually the Malaysian Smart Factory program. So we actually are their sales partner, and we actually help them actually organize certain events as well at the same time. And hopefully at the end of the day, through this sharing program or this educational things that we share, that it makes sense for you all as well. And hopefully you can actually embark on a sustainable way of digitizing your smart factory. Right. Now, without further ado, let me introduce to you who Dr. Chua is. Sorry. So Dr. Chua, a very cheerful guy. Now, he is actually currently the head of Malaysian Smart Factory 4.0 under the Selangor Human Resource Development Center. He obtained his PhD in Control Systems Engineering and the Bachelor's of Engineering in Mechatronics Engineering from the Monash University, Malaysia. His key area of expertise lies mainly in the area of control and automation systems, fault detection and identification, and predictive maintenance strategies, which are widely used in Industry 4.0 applications. He is also appointed by the Malaysian Productivity Corporation in collaboration with the Machinery and Equipment Productivity Nexus as one of the mentors for Productivity 1010, an initiative to support the industries in their journey towards digital transformation. As the head of Malaysian Smart Factory 4.0, Dr. Chua and his team are focused in delivering high-impact talent development programs to accelerate the growth of local talents who will be the workforce in supporting the growth of Industry 4.0. The programs developed by his team at the Malaysian Smart Factory are also able to support the industries and community towards achieving sustainable digital transformation through high-impact development strategies. Thank you very much for your patience. So, Dr. Chua, I would normally say the floor is yours, but unfortunately, we're not on the floor. So, but the screen is yours now. Yeah. Give me a minute. Let me stop my sharing here.
Sure. Thank you very much, Kenneth, for the quick introduction. So let me put up my screen for everyone here today. So I've just shared my screen. Hopefully it's up, and hopefully now it is in full screen. Okay, so a very good morning, everybody. Thank you very much for joining us in this session this morning today. I hope everyone is well and good. And this morning, what we will talk about in the sharing this morning, right, as what the theme of the event is today is about operational technologies and can we really get machines to talk to us, right? And this is actually a very key concept of Industry 4.0, where we talk about machine-to-machine communication and, of course, machine-to-human communication, right? We want to, understand, right, what are the possibilities of communicating with the machines and how we can utilize that kind of information or communication from machines to be able to make the right decisions at the right time, and of course, make faster decision-making process as well, right? So the topic of my talk today will be getting machines to talk through data automation. And how we do that is using or utilizing smart factory enabling technologies, which I will share with you today. Right, so we'll go through a few topics this morning. So one of it will be the importance and value of data in a smart factory. Right, I think that is a very, very important topic because many people always think that Industry 4.0 is all about automation. Right, however, we usually provide a different perspective where, Industry 4.0 is more about data and connectivity. Automation is actually part of Industry 3.0, which I will talk about a bit more later. Now, the next topic we'll talk about also is how do machines communicate, right? When we spoke to many industries, right, many factory owners, right, the problem there is that, they understand what Industry 4.0 is all about, the bigger picture, right? But when it comes to really going into details of how machines talk to each other, many a time they have a lot of questions, right, on how they communicate. And it's really not a very magical concept, but this is something that I will share with you today. And of course, at the end, we'll talk about a step-by-step approach on how to get machines to communicate to each other. So Industry 4.0, as you all have seen this chart probably a number of times, right? Why I put this up again is to actually emphasize on the fact that Industry 4.0 is about connectivity. Right, it is about connected devices providing data and information in real time for industries to be able to make the right decisions, right? And making the right decisions also mean that you are making data-driven decisions rather than gut feeling decisions, right? So through Industry 4.0 technologies, that's where you are able to actually understand what your machines are trying to tell you and what the overall data and trends are trying to tell you in terms of your production productivity, right? Now, the understanding of the value of data, right, comes from the concept of the DIKW pyramid. DIKW stands for data, information, knowledge, and wisdom, right? So what this means is basically when you have much data, right, a lot of data from the factory floor, what happens is that you have basically a lot of information, right? And this information then translates to knowledge, right? Knowledge about your production, knowledge about your machine, knowledge about your process, right? And from that knowledge, right, what happens if you have a lot of data, a lot of information, a lot of knowledge, eventually what it becomes wisdom, right? And wisdom will then be able to, help you to make better decisions in the future because you know your process inside out, you know the trends, you know the analysis, you are the subject matter expert, and therefore you can take your process or production to the next level, right? So we talk about wisdom where you can forecast data and information to make more predictive and prescriptive decisions for the future. So the stages of Industry 4.0 over here, how do you get from data to wisdom, right? It's all about digitalization as a first step, right? When we talk about this is looking at the graph of the stages and the value created from it. So of course, when you have a lot of data, you need to make sure that you are computerized, you're connected. Therefore, the data will give you visibility, right? Understanding it will give you transparency, right? The information that you get will help you to make more predictive capacity. That means what will happen, right? Eventually. And of course, the one that creates the most value is what can you do with that data and what do you have to do next, right? Which is more on the prescriptive and adaptability kind of concept, right? Where you can look into systems that are self-optimizing, you can look into production capacities that will give you suggestion on what to do next. For example, how Facebook and Instagram all works, right? By creating sales, right? It's basically by providing suggestive posts for you to create value and for you to purchase products, right? So all these are basically based on data that is created by you on a daily basis. So the 4 types of data analytics actually comes back to what is data trying to tell you, right? How is the machine trying to communicate to you through data that you gather from the machine? So we start from descriptive. Descriptive means what is happening, right? In a current production system, it's basically telling you what is actually happening in your current system, what is actually happening in your production capacity. And of course, the next thing is diagnostic, right? Why is it happening? So the question of, let's say, machine is down, why is it happening? You know, and usually a lot of times when the machine is down, we don't record why is it you know, actually having a downtime, right? We just straight away up the machine and just left it be, right? So all these are not data-driven strategies, right? But if you actually you know, log the downtime, you actually log the root cause, you're actually able to then achieve what we call as predictive capacity, what's likely to happen, right? Based on the data that you collect from the machine, what the behavior that you see in the machine. And of course, the prescriptive part will be, what do I do next, right? So it increases in complexity over time, but the value created from this kind of data analytics strategy, from descriptive to prescriptive, actually gives you a lot more value to create for your industry to then be able to grow more effectively. Now, if we translate raw data from machines, right, to useful information and to human readable information for us to see, is basically looking at a Google Translate for a machine, right? When we look at communication between humans to humans, we talk in multiple languages, right? Like today, the webinar is spoken in English, but we can also communicate in different languages, maybe 1 or 2 or 3 more, right? So machines are the same, right? They also have communication languages, right? Which we call them as protocols, right? And these protocols then provide you what we call as data, right? So the machine, when it is running, it is also providing you information on what is actually happening. So imagine if you collect raw data from the machine and it is able to, you are able to translate what the machine is trying to tell you. For example, in this sense, you know, you're taking data from the motor, right? So the motor is then trying to tell you that something is happening, right? Anomaly is detected, right? That is descriptive analytics. So then diagnostic will be, why is it happening? Motor has some problems, right? What is likely to happen next? The machine will shut down in 15 minutes. So prescriptive will be, what do I need to do in this time? So the machine will tell you, please prepare spare part replacement, right? So this is how you get machines to talk to you in a language that you understand, right? And therefore you are able to see what to do next and how to improve your production processes. So the next step of it will be, how do machines communicate, right? I think this question is always asked, right? Like, and it always looks complex and complicated, but what I'm trying to share with you today is actually not very difficult, right? It's about understanding the right languages that the machines communicate and how to actually you know, leverage on that to actually help you to connect machines together and then help you to generate data for yourself. So if we look at the whole automation pyramid, right? We talk about the automation pyramid from the field level all the way to the ERP system, right? Everybody talks about ERP today, right? So you talk about field level, which is your sensors and actuators. You talk about your control level, which is your PLC. Supervisory level, which is your you know, supervisory control and data acquisition. MES is your manufacturing execution system, and then ERP is enterprise resource planning. Now, the key question here is, how do you connect from field all the way to ERP, right? Where we talk about vertical data communication, right? How do your field level sensors talk to your ERP, right? How do your field level sensors talk to your control level, supervisory, MES, and ERP, right? It looks like a long stage. Now, it's not only vertical data communication. Now you also have horizontal data communication, right? How do each sensor and actuator talk to each other? How do two different machines at the control level talk to each other, right? And how do your MES systems, if you have a few from multiple sites, how do they communicate with each other? Now, this is actually the key question and the key strength on how Industry 4.0 is generating value for the industry. Now, data communication for machines is not something that is magical, right? Basically, machines speak to each other in a common language, right? So from the very, very basic level, it is basically raw signals coming from machines, right? Coming from your sensors. It can either be analog, which is basically, you know, variation in measurements. So analog signals comes from like temperature, humidity, you know, distance measurements. So those are all analog signals. Digital signals are basically ones or zeros. Ones or zeros means it's either on or off, right? So let's say if you look at your production systems, what are your digital and what are your analog signals from a machine? So a very common one would be digital signals come from your tower lights, your traffic light, red, green, and yellow. So it's either red light on or green light on. right? 1 or 0. So some machines, you have temperature sensors, right? So then temperature sensors are your analog signals. So this can already tell you what is happening in a machine from having an analog and digital signal, right? Now, the next part of it, which is a bit more advanced, will be how do machines talk to each other in what we call as communication protocols or machine languages, right? So machines have a way to talk to each other, right? And when you buy machines, it is always important to know what are the possible ports or communication, ports that your machine can speak to each other. So the most common type of protocol is Modbus, right? Modbus protocol is a standard that has been around for many, many years. So therefore, many of your machines would have this connected communication protocol or language, right? But some machines have more than one languages that it can speak with, right? For example, if you look at the IO-Link hub over here, right, which I think Gerard will speak more about this later on, it can speak in multiple languages. So if you think about it, it is like a central hub that translates machine information or machine languages, right? So if you speak in English, it'll translate in Bahasa. So for example, in the machine languages, if you speak in Modbus, it can also speak in OPCOA, Profinet, Ethernet IP, or many, many others, so that this creates a better translation, right? Or a middle translation between machine and devices. So then if you look at the entire communication strategy, right, from sensor level to field level to all the way to MES level and ERP, right? So from field level sensors, you can connect to a hub, right? Which is basically, it can either be a gateway or it can be an IO-Link technology, right? And this controller level, you can speak in multiple languages. The most common one, it will be Modbus. Profinet will be more Siemens-centric. Ethernet IP are also available. So these are communication strategies to the control level sensors. Now, if you want to talk to your systems in ERP or even in MES, some of the common protocols are like MQTT, right? OPCOA, or even what we call as REST API, right? So understanding machine communication protocols are very important because that will actually help you to drive your machine communication in a much more simpler manner. So as long as you understand what language that they are speaking with, it's already possible for you to gather that data, gather that information, and then you can drive your technology productivity to the next level. So when we collect a lot of data from the machines through a lot of communication protocol and strategies, right, then data is then used to give you a story, right, to tell you a story of what is actually happening to your machine, what is actually happening to your production line, right? So we call it data storytelling, right, through real-time visualization, right? So the most simple way of data storytelling, right, is when you implement OEE in your current production system, what story is it trying to tell you from this availability, performance, and quality, right? So from collection of that data, right, if you put the right strategies in line, right, it will tell you a story of your 6 big losses, right? Every day it will tell you a story of your 6 big losses. So today, your losses are how much in breakdowns, how much in setup and adjustments, how much is in idling, your speed, your defects, and then your startup losses. So every day it will tell you a different story about your 6 big losses, right? And it will tell you where your wastages are, right? And therefore, by minimizing your wastages, right, minimizing your losses, therefore you are able to then improve your productivity and improve profitability, right? Because you reduce your wastages. Everybody has 24 hours in a day, right? Regardless of how much we want to expand our production, the limit is always 24 hours in a day. How much waste can you reduce, or how much total productive time that you can enhance within a 24-hour cycle? So then data is then used to tell you a story of what's happening with your machines through different behavioral trend analysis, right? So an example would be a car, right? You're driving a car, and if there's a problem in your car, they will give you signals, right? They will tell you a spanner signal or many, many different signals, indication that your car has a problem. What if it doesn't give you any signal or any indication at all? What's going to happen is that you're going to drive your car until it starts to heat up, and then suddenly you have a smoke coming out from your bonnet. And when you have smoke coming out from your bonnet, you start to know that your car is going to break down any moment already, right? So you don't want to have that level of possibility happening. So what happens is that, cars these days, they will have other sensors that will indicate, problems at the early stage, so that you have time to then drive your car to the service center and go and fix the problem, right? Before some other major consequences will happen. So this is how data is being used to tell you a story of your current production system, right? We do have many experts, right, who have been working in the industry for 20 over years. When they walk past the machine and they hear the machine give you like very, very funny sounds, like, they know that the machine has a problem, but it is not data driven, right? It is based on experience. But now you want to use data to be able to validate that the machine has a problem happening, right? So this is how machine data is being used to tell you a story. Now, from data as well, you can also see trends, right, over time. And these trends are basically only understood by subject matter experts in the industry, because you have the domain expertise of what is actually happening in your industry at the moment. So, for example, this chart over here, if I put it up and I show to anybody, right, can you tell me what is happening in this data set? It is actually very difficult for someone who is not in that particular industry to be able to tell you what is actually happening in this particular data set, except that, it looks like it's different at the beginning, and then after that, it looks a bit more standard throughout the next days, right? So what I'm trying to emphasize here is that, the domain expertise in the industry is very important to tell the right story, right? If you don't have the domain expertise, you'll be telling different stories about this trend, and then everybody will have a different story, right? So as an expert, you are the one that will know exactly what the story is supposed to be, right? In this particular chart over here. So the importance of data, right, is key in Industry 4.0 now, right? It's not so much about automation anymore, because a lot of times by having the right data, you are able to actually minimize certain losses. You are able to actually minimize the gaps in your production systems, and you have greater visibility on where you can improve, right? So when you have a lot of data, when you talk about volume, right, you have abundance of it, you can already start to see your trends. Now, velocity is, of course, the speed of when your data is being generated. Is it every 24 hours, every 12 hours, or every 1 minute, right? What is the velocity of your data being generated? Then you talk about variety, right? You need to collect multiple types of data to be able to make better decisions, right? Veracity is basically your accuracy of your data. You don't want to collect data that is not accurate, and then therefore you make wrong decisions, right? And of course, understanding the value of the data, right? The value of it is very, very important. You don't want to collect data that doesn't make sense, that doesn't create value, and therefore it's considered as redundant, right? So when you have the right data storytelling, in your current manufacturing production system, and get your machines to talk to you, right? You're able to have many advantages already, right? Improving machine utilization, reduction in maintenance costs, reduction in downtime, and many others. There are many key advantages of getting machines to talk to you, right? And therefore, you are able to be able to drive better productivity and efficiency in your manufacturing operations. So now, I have shared with you on how do machines communicate, what is the importance of data. But of course, the next step of it is, what is a step-by-step approach to start your journey in terms of getting your machines to talk to you, right? So for us, technologies should always be modular, compatible, flexible, and scalable, right? Why we always talk about this concept is because, technologies nowadays, it changes very, very fast, right? Every year you have a new Huawei phone coming out, a new Honor phone coming out. Every year technology changes. From 10 megapixel, now you have 100 megapixel phone, right? So every year technology changes very quickly, and therefore you shouldn't be limited by the technology that you have today, right? You should be able to then scale up modularly throughout the years that you are operating your industry. So when we talk about technologies and we talk about compatibility, we talk about open communications, right? Flexible communications and scalable integrations, right? And therefore reducing your overall complexity and reducing your overall cost of integration. So for many of the SMEs especially, we always help them to see where they want to get started, right? So a lot of them, they want to go into analytics, they want to go into AI, right? Which is very aspirational, it's very, very good, right? But one key problem there is that machines learn through data, right? And if you don't have data, therefore it's very, very difficult for them to learn. They can learn, but it may not be accurate, right? So therefore, we talk about data generation as a level 1, the first step. Then we talk about data visualization, the second step. Level 3 is data storage. Now you need to store your data because you want to look at historian trends. You don't want to just see yesterday's trend and then forget about the rest of the days, right? Then you talk about formulation, where you want to create valuable insight for your production like OEE. Then only we talk about analytics, right? What is your predictive capacity and what is your prescriptive capacity through data analytics strategy? So when you look at the entire production system, right, we always start off with the ground level of level 1, right? Collect data from your machine first. Now, a key question of people usually asking is that my machine is 10, 15 years old already, right? It doesn't have IoT capability. It doesn't have, all these ports, it's basically locked, right? I can't do anything with it. It's not that you can't do anything with it. There is possibility to integrate or retrofit to collect data from machines. And that is something that you can achieve in level 1, right? You can just pull data or signals from the machine. Remember your digital or analog, right? Pull that signal, gather that data, formulate a OEE strategy from there. Now, then you talk about level 2 and 3, where you want to log data, store data, and visualize. Then you want to look at OEE, then only you see your analytics strategy. So once you actually start this key concept over here, right? How do you want to get started? Look for the right hardware that you can collect data with. That is the most key important, right? So you talk about IoT gateways, right? Where you can collect data from your analog or digital input. Then you talk about IO-Link technologies where you can pull data and information and it becomes a central hub to communicate with multiple and different protocols throughout your integration process. So understanding that communication protocols, understanding your hardware and devices, language capabilities will help you to make the right decisions, on the hardware purchase that you need eventually. Now, all these technologies, then you know what are the hardware. Now, what is the next thing? Next thing is the software. When you want to connect your systems together and integrate them together, look for platforms that are highly scalable and open for you to integrate and communicate, right? You need to look at strategies where, it is a multi-level communication, it is an open protocol, and it is supported by a community to help you drive that kind of integration. So, from data collection, straight away, you can visualize dashboards like this, straight away get your OEE information and straight away move on from there, right? And therefore, these kind of technologies will help you to gather insights. Now, this is only for one machine, but you want to then see multiple machine communication. So your technology that you invest in, right, that you want to invest in has to be scalable to multiple platforms, right? And therefore, you are able to visualize data from across your factory line, right? And you're able to control information that is going through, right? Make the right decisions and then make the right communication strategies, right? And then, of course, when you want to scale up, you want to look at further information, trends, and analysis. There are many platforms out there that are available for you to explore, right? Nowadays, technologies move very quickly. There are many platforms for you to explore, and this is an area where we can help to support industries to learn how to build platforms like this, right? And this is actually very, very sustainable, right? And based on our previous webinar series with Mesa Worldwide, we have also gotten an industry panel to share how they have started their journey through developing these platforms on their own, right? Through our training methodologies. So we talk about, modularity, we talk about flexibility, scalability, and compatibility. Why that is a key importance in the whole smart factory integration is because you want to ensure that, you have a cost-effective and sustainable integration for the future, right? And you want to ensure that there are open and scalable technologies, lower upfront investment, and technologies that are readiness to replicate, right? And when we talk about technologies, right, putting in a technology and plug and play does not mean that it is Industry 4.0 already, right? You still have a journey to go where you look at level 1 to level 5 just now, right? What about the analytics part, right? If you want to do data analytics, you have to have access to all the platforms that you're doing to make the right configurations to suit your particular industry. So eventually there's a lot of customization, there's a lot of, R&D required, to actually move to the next step and the next step and the next step, right? So when you work with open and scalable technologies, technologies that are ready to replicate, that are sustainable to grow in the future, you create what we call as maximum value, right? And we always advocate for ownership and active customization for industries so that they are able to then translate whatever that they have learned into real valuable assets for the company, right? The question is always, whether should you, build your own technologies in your current industry. And we always say that that is actually possible, right? So when you have digital transformation ownership, you have sustainable technology integration. What happens next is you actually reduce your cost of integration and improve your ROI very, very effectively, right? So the key part or the key takeaway that I would like to share is, when you look into integration of machine communication, when you want to get machines to talk to each other, always think about whether they have multiple support languages for communication, whether is it modular, how you want to connect different machines across your automation pyramid. That's very, very important. So those are the key concept and aspect of how you want to decide your investment for the next step. Okay, so SHRDC, we support industries to actually move forward in terms of Industry 4.0 through training methodologies, right? So if you do want to get in touch with us, this is how you can, or you can also get in touch with us through Method Worldwide. We are more than happy to support you through your journey. All right, with that, that's all I have to share this morning. Kenneth?
Thank you, Dr. Chua. Thank you very much. Certainly very insightful, actually. So just to share, just to recap what Dr. Chua has mentioned earlier for all of us here as well. I think there's a question as well by John asking for the slides later. So let me discuss with Dr. Chua and see whether we can actually share those slides. Yeah. But in short, we always have this question: can we really get those machines to speak to each other and those kind of things? And it's always a big topic as well, and especially if we have legacy machines. So what happened previously in some of our talks and discussions earlier, especially when Dr. Chua mentioned about industry expert. So actually, the guy is actually James Chung from APM Springs, and he actually discussed, and he actually shared something very interesting where they discuss about if the key two words that he actually spoke about was actually information automation, where this is where we lead towards what Dr. Chua mentioned earlier about how we generate data and then how we visualize those data. And of course, eventually, how do we store them? How do we formulate them? And how do we analyze these data as well? So which will lead to eventually AI. I'm not saying that, I'm sorry, no disrespect to AI. I'm sure it is fantastic, but we need the data first. So in this case, I think in some of our discussions with Dr. Chua as well, so machine learns from data. So if they have enough data, then they can actually predict better as well. But for us, we talk about, who makan garam a bit more lah. So if you makan garam a bit more and those kind of things, so we know more or less whether, if we listen to the machine, we know whether the machine is sick or not lah. All right, but let's hope we don't want to go down that road. But nowadays, everything is about optimization. All right, thank you very much, Dr. Chua. See now, let me share screen a bit. So thank you very much again, Dr. Chua. So next, I want to introduce to you is Gerard. Now, Gerard is from pepperl+fuchs. Now, he has decades of experience leading factory transformation in various MNCs globally, from FMCGs to oil and gas. His latest role in P&F helps industrial companies in the APAC region future-proof against technical and business challenges. Thank you very much. Gerard, if you are there. You are muted, sorry.
Yes, I am. Thank you for the kind introduction.
Thank you, Gerard. So the screen is yours now.
Thank you. Thank you. Good morning, everybody. How's everybody doing? Had your breakfast, I hope? Okay. My name is Gerard. Thank you, Kenneth, for the kind introduction. I guess my screen is working. Great. So I never knew I had to say this before I give a lot of public talks. I never knew I had to say this, but forgive me if my kids it becomes a bit rowdy. Working from home is a different sort of challenge, so forgive me for that. And I want to start off the first slide with something to do with my kids as well. I was attending the art class with my kids virtually, by the way, and then the theme was the future. It was a very interesting theme. It got us and got me thinking, oh, how do I envision the future? But when I look around me, I got to say, hey, the future is now. Just look at the automotive industry. Years ago, you never imagined flying cars like Back to the Future, but it's here. In Singapore, we are setting up a Hyundai motor group, and it's all autonomous. Right? This is almost a lights-off factory where you can see how your cars are built. You can customize how your cars are built, very, very much like Tesla. So how do they do that? Obviously, it's all to do with data. They have all the data on hand, and you can customize to how you will like it. All right. And of course, as the sentence over here mentions, the facility will employ various and advanced manufacturing and logistics systems, including AI, IoT, and different kinds of robotics. Another thing that struck me, and it has to do with everyday life. I'm in lockdown. I think you guys are as well. So what's the thing that we use most? We use online. We do a lot of online shopping. My wife does a lot of online shopping. I do a lot of online shopping. And Amazon is one of the key areas, one of the platforms we use a lot of. And how does Amazon work? They have thousands, hundreds of thousands of robots working in its warehouses, right? You can look on YouTube and look at how their warehouses work. It's amazing. The concept is so simple as well. There's YouTube videos that tell you how they implement it, how they adopt it. So it's everywhere we go now, there are robots, there are autonomous cars, and it's all around us. Last but not least is our governments around us are also automating smart cities, right? Malaysia is also doing it in the sanitization department, if I'm not mistaken. So in the chat, I have shared a link where you can, which I'm going to show you right now. Just a quick example. I did this on the fly, so just wanted to do a quick example to show you. If you can see my screen, I guess you guys can. Right, look, this is the link that is inside I put into the chat. It's amazing. This is where citizens can monitor the health, the weather, the PM particles where haze is around, for example. And this is the map, all right? And then you can screenshot, like for example, I chose schools over here. You can choose a particular school and you can zoom in the different areas. You can see the map moving. You can select the date range of the data that you want. And this is what Dr. Chua talked about in terms of data, in terms of automation. It all starts from the beginning. This is really the high level and where the end users come into play. And this does a lot of, helps a lot of real-time reporting as well. All right, go ahead. I'm not going to talk so much about it. You can play with it at your own free time. And this is powered by Microsoft BI, which is I'll talk about little later as well. Okay, now back to the slides. Okay, so now it all starts with a vision and a destination. That's very important. When you automate, you have to have the end goal in mind. All right, and a vision, which is the management, and the destination, where you want to bring the company to. I work in many MNCs, right? And I know the KPIs from top to bottom, right? Every time we do a project, it's always about KPIs. What are you going to bring to the table? How does automation help me? Here are some common KPIs, 4 to be exact, and some of the most common technological use out there in the market. Okay, I'm putting all the examples that everybody can relate to. Look at this tennis ball over here. Everybody watches, I think a lot of people watch sports. This is using vision systems over here. And in a very fanciful term in the market, the company called a hawk eye system. I think the Euro 2020 is happening. I think everybody watches it, and they employ goal line technology that use a Hawkeye system, and that is a vision system. It makes umpires and referees makes better informed decisions, and that means your quality, the products you send out, you know that it is of good quality that you send out, right? No matter what product that you use. And where can you use it? There's so many areas you can use it. Production, material handling. Nobody got fired, by the way, right? I mean, if you look at the World Cup, there's still a referee and 2 linesmen running down the slides, right? So the staff is still retained. They are just being trained to handle the quality a little bit better. So upscaling, right? The skill set, that's what I'm trying to say over here. Next. All right, as I mentioned, lockdown. Okay, everybody uses food apps, right? In Singapore, that's where I am, that's across the causeway. We have to order food through our apps as well. We can't go anywhere. I imagine Malaysia distance is a bit longer, so they have to go through apps as well, perhaps. So everybody is forced to adopt a technology over here. And what are these technologies? RFID and barcodes. Okay, how many of us order things online and they send right to your doorstep? And what do? To certify that it has been delivered and where it is all using RFID and barcodes. So it improves the service levels, and it deliver, for example, your company says, I can deliver within a day. And I promise you, I can deliver within a day. Bam, there we go. You can track the logistics from the start all the way to the end. And how do they do that? RFID, barcodes, and all of us use perhaps DHL. That is the most classic example. You can go to the track, you can track every step of the way where it is, or if you use Food Panda and Grab, you can see where all your location of your parcel or your service is. Okay. Capacity. A lot of people ask me, hey Gerard, I want to automate, okay, but I have limited footprint because rental is so expensive, especially in Singapore. Well, capacity is a crux, but that we can solve it as well. We can automate, and this is Amazon warehouse where you can see, by the way, the rows of racks are packed back to back. Okay, so they expand their capacity, they explode their capacity 2 times within the same footprint. Keyword over here, that's their KPI. Okay, some people are more, of course, ambitious. I want 3 or 4 times. That's up to you. If you have the height, of course, right? There's many ways you can go around doing that. And how do they do that? As I mentioned at the start, have a look at how Amazon does it on YouTube. It's a very quick video, all right? They use robots and sensors, and in Malaysia, I think the robots company's name is called DF Automation. They do a lot of automating of robots as well. So there are many robot companies they can approach out there as well to help you out, to partner with you if you do not know. Okay, or you can approach pepperl+fuchs, and pepperl+fuchs can recommend you guys the same some vendors that you can approach to. And what you can improve in terms of capacity, of course, production and your warehousing. Last but not least, management. A lot of people tell me, hey Gerard, I would like to reduce my costs by cutting labor. But I share a lot of times, I share with the management, that is not really true. If you cut your costs, it's not really true labor. You have to do all the things in front, and you can improve it through business intelligence. Why do I say that? Where, if you think about it, where do you spend most of your time in office? You spend it in meetings, right? And in a meeting, perhaps you have 8 other executives in that same meeting. And in that meeting, you perhaps ask for updates, right? Where dashboards, where I show you the perf example earlier, you can pull it out without calling everybody into the meeting. And you can save costs through avoidance of meetings, avoidance of emails and such things. So your productivity in effect is raised, it's domino effect. Of course, it takes time, it's a step by step, all right? And this is done, by the way, through OPCUA, which is something that Dr. Chua talk about later, which I'll talk about later as well. So some of there are key standard reporting tools out there you can leverage on as well. And here are some of them. It's Microsoft Power BI, and of course, Tableau. And this covered the entire factory, all right? You can put television screens across your factory, and everybody can see where they are, where their KPIs are on the shop floor, right? So that's a dashboard for everybody. And that's how you cut costs, right? So think about it. Okay, and when you think about it, you realize that, as Dr. Chua mentioned earlier, data is at the heart of the matter. Why do I say that? Okay, this is, I'm giving you a roadmap on how Pepperl+Fuchs envision Industrial 4.0. We've given it a very fanciful name. We call it Sensoric 4.0. I won't emphasize too much because Dr. Chua has already covered most of the points, but it really starts with selecting the right products. Do not worry. There are many people out there that can guide you and handhold you to select the right products, and we can work together and partner together to get to your end goal, which, what I said earlier, is your destination. Once you have your vision and your destination, we can get there so much easier. So it really starts with the smart products and smart sensors. Sensors and data and products that can give you data with a snap of a finger, without you having to compute, right? Maybe, like do speed calculation, where you can enter a formula. No, something that is already on the fly. They can give you the data. That's at a snap of finger, quick and easy. And with all these data, sensors, and products, and that's where the magic happens. And that's where you can put all these into processes. All right. And everybody wants to automate your processes, wants to make sure that for example, your logistics, you want to make sure the truck guys who are trucking your products are staying only so little, only staying a right amount of time in your warehouse, so the goods are immediately loaded into the trucks and off it goes. It spends minimal time in the canteen or wherever, right? So all these are automating of processes, and processes are often and not the most challenging because there's cross department and there's cross level in terms from your ordinary worker to all the way to upper management. So there are many ways to cut the pie, but once you have data, you can cut the pie appropriately as you wish to. Now, scalability, I would like to talk in particular, there are many technologies out there, but I would like to talk in particular this technology called IO-Link. It all started about 20 years ago. Sorry, let me count. 15 years ago, right? By tens of companies. Pepperl+Fuchs is one of the founding members. And how can you tell? Because you can tell when you load the program or load the device, it'll tell you our vendor ID is #1 because Pepperl+Fuchs is the pioneer in that. All right, which I won't show you today. When it comes to the time, we'll show it to you appropriately. And it really cuts to the different levels. I love this picture because it shows you the different levels and how it works. As I mentioned, get the smart data in by buying the right products. Here you have RFID, you have optical sensors, you have light grids, you have valves, you have motors, you have many others that are over here. And all of them, if you want to, how do I know whether these products have IO-Link? Just ask your vendor, and you usually have this symbol on it, or it'll be articulated in the manual and the data sheet, whatever not. All right. And IO-Link is something that I love because it can go all the way from the sensor level all the way to the cloud. All right. So you can control all these via one master. Right, when you can plug all this, and it's really a plug and play. I wish I have the time to demonstrate to you, but it's easy. All right, it's a no-brainer. It doesn't need to plug and play. The technicians love it. The engineering assistants love it because it's so simple to program. The learning curve is not very steep at all. All right, and as you can see, the architecture here is simple. If you want to utilize your PLC and your PC, it is easy peasy. You can see that you can do it over here. If you have a HMI as well, no problem. We can connect it via a switch. And last but not least, and say, Gerard, I would like to go straight to the cloud. I don't really want PLCs. I'm upgrading all the way. No problem as well. We can go all the way to the cloud. As you can see over here, there's Microsoft Azure, there's Amazon AWS, and SCADA servers. So many possibilities. And the beauty of this is there is a multi-link capability. This multi-link capability enhances and enables, the keywords enables companies who are still using PLC and will love the transition to the cloud, because our IO-Link master is able to simultaneously transmit data to the PLC and to the cloud. So hence, you do not have to have a hard cut right? In between, when you run the row technology, you can plan it in the soft row, in other words. And this is very good for whoever is planning out there, who is, or the automation guys or the network guys who are doing the planning. And it buys them time to migrate to where they want to go. And with this, and this is great because it's the technology used is independent from the platform used. So regardless, I'm using Linux, I'm using a Linux from my iPC, or I'm using Windows from my PC, doesn't matter, we still can do it. And does it have to be all from the same vendor? Because of course we love to cover all areas. Every vendor would love to cover all areas, but sometimes it is just not possible. And IO-Link is really friendly. All right, it's like a United Nations coming together and coming for a common good over here. So that's what they do. They say that it doesn't matter if your vendor is ABC, I can support you as long as it's IO-Link. All right, and there we go. That's a promise from these consortium that is driving IO-Link as a technology. OPCUA and MQTT is really independent of your programming environment. Notice the word I'm using, the word independent as well, because that gives everybody leverage. It is open source. That is meant, you can just Google it, the different programming methods. You can use C++, Java, .NET. If you have a system engineer, it's easy for you. You just program it whatever you need to, extract the information. I'm not the system engineer. Sorry to say, but my system engineers, they did it within a week, right? To implement whatever they need to do. Of course, the scope matters, depending on how big your scope is. Last but not least, I think the word scalable has been mentioned a lot of times. So this can really be a platform to build your different programs, your different ideology on it. And there are many predefined APIs and development kits out there to help you out, to scale it to whichever way that you want to. Now let's look at some example. All right, we have many customers coming to us in pepperl+fuchs and other companies as well, who are in the midst of transiting, or who wish to transit over here. Here, there's a CNC machine, and they are using non-IO-Link spindles. And of course, if anybody who uses a CNC machine, and you'll know that some of the machinery parts are hard to reach or are in dangerous positions, and they will not like to go there unnecessarily unless they really have to. So what happens is that they have minimal access to diagnostic information, and they really want to know when it breaks down, because as they mentioned, they want to do preventive maintenance, because ultimately IO-Link is able to provide you with all the service data and all the events that you can tell the technicians, hey, look, I have maybe 4 hours left of life cycle in my in this equipment. So hence, maybe it's time to be replaced. The technician, upon looking at this, they say, oh yeah, that's true. Let's replace it before it breaks down. And that saves you a lot of downtime, unnecessary downtime or changeover. So as I mentioned, the challenge here was they wanted to have a spindle that could communicate necessary data and diagnostic. Pepperl+fuchs is not in the business of building IO-Link spindle. So this is a very classic example of a product of IO-Link spindle that is not from Pepperl+fuchs, but yet still can be integrated into our IO-Link master. So we package it to our Modbus TCP messages. So Modbus is quite an old protocol. So we understand that, and we made it available for everybody to communicate, and we're able to send it to the customer's control system after that. And what benefits does it bring? You can free up all the trap data. Imagine it can tell you the temperature, it can tell you the vibration, and all these data is a domino effect, can give you a sense of when it's going to break down. It can enable you to do all the predictive maintenance with all these insights, to valuable insights. So this is one classic example of a company that would like to transit from a non-IO-Link to an IO-Link capability and to utilize the data. Next is a company that has something more. They want to do more than just using the PLCs, and they want to use, now in this case, they want to use the clouds. Now, this is a very famous company that is, has a fully equipped automated warehouse, and they would like to use the external third-party broker to send information to. Now, whoever uses the internet know we have this thing called firewall. I think a very famous example is the firewall of China. In China, you can't use Google and you can't use YouTube because the firewall blocks you out. And in our countries, Malaysia, Singapore, doesn't matter where we are, we too have this firewall. So imagine, right? If I'm ordering Amazon parcel, for example, if all these firewalls block this information out, we won't be able to track our parcels. So what was the way around that? We have a third-party broker where our data is sent from our IO-Link device over here. It sends to the broker, and then you can pull this information as long as it's subscribed. So it's a publish and subscribe information. The keyword over here is unsolicited or solicited. For firewalls, they block out all unsolicited data. So in case there's virus, you won't be attacked, or it blocks out all the spam. But if you subscribe, you purposely subscribe or solicit the data, then yes, the data will come to you. And that's how MQTT works. And that's how companies get to reap the benefit of, sorry, in case it's a bit noisy in the background, I stay next to the airport. So the airplanes are flying. Yeah, it's military aircrafts, in case you're wondering. Yeah. So, yeah, okay, the aircraft has passed. Okay, so they can script, they can get all these data and reap the benefits of this. So now, for management who wants to see what's happening in the factory worldwide, or they can do so, of course, via the phone. And this is a very good benefit, and it's through the clouds. Right, so this I'm showing you two very contrasting ways of managing data, and whether how do you want to load the data, whether it's intranet, internet, or through the PLC. So there are many ways you can do around that. Now, sorry. So from pepperl+fuchs, we have all the depth and breadth of our IO-Link sensors. You can see over there, we have inductive sensors, we have photoelectric sensors, we have ultrasonic sensors. It's really a holistic, and it can really covers all the ranges. So if you have time, speak with us first, and then you can see how we can help you out over here. All right, and these slides over here shows you all the architecture, which I'm sure Dr. Chua has touched on earlier. And I really love the way that it was articulated earlier: modular, compatible, flexible, and scalable. I thought that was a very great takeaway, key points I took from the last presentation. And I will say that with these products, you can achieve it. All right. And with that, I will hand it back to Kenneth, unless there's anybody that has any questions on the floor. Thank you.
Thank you, Gerard. Fantastic. So seems like this IO-Link, right? I remember we spoke about this previously, Dr. Chua. So sorry, Gerard, just to bring up what happened previously.
Sure.
Yeah. So what happened was in our previous setting, we also spoke with Baloof Automation, and they discussed about IO-Link as well. And today we're talking about IO-Link again. So it seems like IO-Link seems to be like the mother of all communication protocols, if I'm right? Correct me if I'm wrong, gentlemen. That it seems you can connect even both the hardware and it goes all the way down to the cloud as well. So it depends very much on how we want to implement it as well. So just to pick a few points from Gerard before we go into the Q&A shortly. So it seems that automation, I mean, of course, there are various levels of automation within the company of yours, right? So it depends very much on how we want to go ahead with it. So I think Gerard and Dr. Chua also mentioned earlier that it starts with your vision and how we get there, right? But getting there doesn't have to be difficult. So getting there, we can always get in touch with Dr. Chua, where we can actually start with lighthouse projects as well, mini projects within your company, then we proceed from there. And then of course, eventually, how we identify these lighthouse projects is actually very simple and very straightforward. So instead of starting a very big project within your company, you can actually start something smaller. Maybe automate. Let's just maybe take a very bad example. Yeah. So we got 2 legacy machines, and we want to and we want to get both legacy machines to talk to each other. And we know we need to get them to talk to each other, you know. So we just use IO-Link here in this case, then we can actually get them to talk to each other already anyway, right? Of course, at the end of the day, the IO-Link from PNF, it really accommodates a lot of communication protocols. So we don't have to really worry too much about whether the machine can really talk to each other or not. But let's just start small, and from there, I think we can actually move further ahead. Of course, Hyundai is in Singapore. They are employing very much, I suppose, high-end or smart factory processes and those kind of things. In fact, I think I read somewhere, and this was 10 years ago, I think, in one of the islands in Korea, they only have like two staff only that actually man the whole island, you know. So and they manufacture a car. So basically everything goes inside from one end, and the output is a car, you know. So it's fantastic. It's very different. And of course, Amazon, we all know Amazon, fantastic. I know they did employ a lot of these, robots in the automated warehousing. And of course, the smart city where Perth was actually used as an example. I'm sure there are other cities out there as well, and I'm sure that you can actually use those data. So moving forward, all right, it seems that IO-Link is very fantastic, as I mentioned earlier as well, and what Gerard mentioned. So you can actually scale it very much, including in CNC machines that does not have, in CNC machines that is not IO-Link ready, so to speak. So you can actually get them ready, all right? And of course, how we actually use them to actually automate a warehouse as well. Now, so moving forward, so ladies and gentlemen, so we are now in a Q&A session, all right? So if you have any questions, please do raise it up. Dr. Chua and of course Gerard will be very happy to take them, all right? But in the meantime, when everybody is still thinking about how do we get questions out, I know we are shy, but we are not too shy. And since we are online as well, so if you're shy, maybe you don't need to switch on your video, but please just ask away. All right, so maybe let me pose this first question, right? So for those of us who are not too sure what an IO-Link is, all right, it seems to me like it's like sort of like a gateway, all right, to a lot of protocols and those kind of things. But am I right to say, so I have a bit of engineering background, so can I just guess it? So IO-Link, does it mean input-output link? So Dr. Chua and Gerard, so maybe you can assist here.
Yep. So for us, IO-Link is pretty much as a hub, right, or a gateway to multiple communication between devices. So that's what I've shared just now, and also Gerard has also shared that entire layer of communication. Yep. Right, it can go all the way from the field level, which is the sensor level, all the way to the cloud, right, or any other levels between the automation pyramid. So we see it as a gateway or a hub towards that connectivity, and how it enables a more effective communication between machines, machines and devices. So that's how we see IO-Link benefiting the industry from this perspective. So maybe Gerard can share more in terms of the technical perspective of it. Gerard, sorry, mute.
Still muted.
Sorry, okay. I'm having some technical difficulties. Okay, anyway, I'm back. Sorry, I didn't catch the question again. Could you repeat again, Dr. Chua? I caught.
No, so it's just the technical, the technical portion of what IO-Link is, because we all know what for some of us here we are not familiar with IO-Link and the term, right? So what is the technical definition of it? Because as per my understanding, it seems like an input-output link where you can connect almost everything.
Yeah. So basically, it is really a point-to-point serial communication protocol. Yeah. So from your device, whatever that is, it goes to a certain point. So hence point to point, and it's communicating and it's used to communicate with your sensors or actuators over there, and it sends this information serially to the IO-Link masters. And all these and for IO-Link, each device they would have the companies who have identified what are the datas, because IO-Link, why is a consortium consortium, as I mentioned. So everybody has a standard to follow. So there's an IEC standard that everybody follows. Hence, no matter which company you buy this IO-Link product from, you have this, you follow this standard, and that's why every master, for every IO-Link, there's a master that can pull all this information through an XML file. So sorry, I'm going a little bit technical now. So it's able to pull all this information out and organize it. I think the keyword here is organize this data into a user-friendly manner. Yeah, so that's what IO-Link is, and it runs preferably on digital. There are of course there are IO-Link that can assist in analog as well, but it is driving towards a digital portion. That's its goal over here for IO-Link. Thanks.
Thank you, Gerard. So in short, ladies and gentlemen, so IO-Link actually, if I understand correctly, so it doesn't matter what kind of sensor you buy it from, as long as they support IO-Link, then you can use those sensors. So in short, so we can actually really get machines to talk to each other then, whether is it legacy or not, you know. Let's see now, what is there? Gentlemen, would there be any questions from the floor? Or everybody very confident on what they feel like? So, Dr. Chua, maybe I can pose you this question, right? So while the audience actually think of something to ask. So earlier we mentioned about data generation and where we lead towards eventually AI. Maybe you can share a bit more of how valuable this data is and how much data should we store actually before we really move towards an AI so-called era.
Yep. So basically, when we want to start looking into analytics and AI, we really need to look at what the machine is trying to tell us in the beginning, right? So when we talk about data generation, we're actually looking at machine trends and processes, right? So every machine, if you notice that every machine moves in a cycle, right? Most of the time it moves in a cycle. So it will have a very standardized movement throughout a period of time, right? So when we talk about AI and analytics, it's basically what do we want to achieve from identifying problems in the machine. So when we look at that P to F curve just now, right? When we buy machines, we never hope for it to fail, right? So when we start to monitor data over a period of time, until the point where we start to see deviation, that's where we start to see that problems are starting to happen, right? So in terms of historical data capture and trends, it can span from a week's worth of data all the way to a few months worth of data, right? Because we never know when the machine is going to fail, right? So data collection needs to be stored within that at least that span. So that means you need to have a big enough data storage capacity to be able to store that much of data. Now, also it looks at the possibilities of, what is the frequency of data collection that you're actually trying to grab. So when we talk about frequency of data, when, let's say if your process runs every 10 minutes is a new cycle, right? So you know that your sampling rate needs to be below 10 minutes, right? Because you want to capture everything within that same cycle. If your process is actually every 10 seconds, then you actually need to sample even smaller. So your sampling rate or your velocity needs to be shorter and shorter and shorter, right? So that's why when we talk about, let's say IO-Link, when we look at vibration sensors, right, we cannot capture it at every 1 minute because capturing vibration every 1 minute may not be able to grasp the full potential of what we are trying to read, right? So that's why from the IO-Link sensors, what we can do is capture, I think now the capacity of the IO-Link sensor is 100 milliseconds. I think, Gerard, you can correct me if I'm wrong. So 100 milliseconds capture. So, that is how fast you can already start to capture your range. And this is what we call as condition monitoring. So from here, then you're able to apply a bit more predictive analytics or predictive maintenance strategies. But AI is also used in a more sense of prescriptive maintenance, right? So when you look at your data, you also need to log what are your possible downtimes, right? So then and what is the possible root cause, right? So we call this actually as a 8D processor, 8D problem solving. So once you actually capture that, then you're able to do better analytics. So it takes a bit of time But by having this kind of mindset of always tracking your data, right, it will actually help you to move to the next level.
All right. Thank you, Dr. Chua.
Yep. So just to interject, the speed, right, of transmission, the data transmission is 230.4 kilovolts. Or that is, I think some people call it beats per second, right? I think that's really, really fast. If we tried with a camera before, and wow, it's still flying. Yeah.
Nice.
Yeah. Okay.
Fantastic. So thank you so much, Gerard and Dr. Chua. So just to ask Gerard as well. So PNF, I mean, you guys are in the sensor business, and I'm sure you assist your customers as well for a lot of other kind of to implement smart factories in their shop floors, definitely, you know. So what was interesting is maybe I know that you share something on the CNC machine and maybe and of course the automated warehousing system as well. Would there be any other so-called other applications that you have come across that which is, I wouldn't say archaic, but maybe really those legacy machines? Will you be able to share maybe one more example?
Yeah. I think a very common application for legacy experience, and my personal experience in Malaysia for our dear Malaysian friends, is machine access. It's as simple as that. Machine access using RFID. I think in Malaysia, there are a lot of specialized equipment that only skilled workers can access to, and they want to use RFID as one of the examples over there. So what do? So they got the IO link in, and because they want to send the information to the cloud, because of course machine access, they want to sometimes either send it to the PLC or to the cloud, so that the managers know, okay, this guy accessed it at the right time, or just as a safety precaution or security precaution in that case. So what they did was they got IO link, the IO link master, which is able to give information to the cloud as well as to the PLC, and they made the employees wear tags, right? Everybody has a card, right, where you can tap onto the basically on the machine. So they install the RFID reader on the machine, and basically you just walk close to it and you just tap it, and it send all this information where they want to go, and it's able to tell when it was tapped, what time it was tapped by who, etc. So many things, a very rich data that is sent over there. So it's a very common example, and that is the simplest and most easiest to implement, I would say it that way. Yeah.
Thank you so much, Gerard. Seems like we can do a lot of things here as well. No? So gentlemen, so ladies, is there no really question from the floor or from the screen? Because I'm running out of questions now. All right, so okay. So since we are done, any questions? If you're too shy, don't worry, no worries. You can actually send us those information as well. You have received our emails anyway. If you have something to share, or maybe ask Gerard or Dr. Chua directly, just do contact us. Don't worry. If in any case as well, we share the YouTube video later as well. Anyway, all right. So just a bit of hello.
Hello. I have a question.
Sure. So please introduce yourself.
I'm Akasha.
Yeah. Hi.
Okay. Actually, normally when we go to the company, the normal question is what is the cost of the improvement to Industry 4.0? For example, if they want to have OEE calculation, so it is a right question if they ask how much they should invest for that particular OEE calculation, or we cannot, or what is your opinion? Can we calculate for them, or what is the budget? What is the cost of the to implement the OEE calculation? Can anybody answer? Give the answer.
Right.
Okay.
Akasha,
can you understand
right?
Ma'am Akasha?
Yeah.
Can you understand my question? Because normally they will ask what is the minimum cost of the implementation of the Industry 4.0. For example, they want to implement calculation of OEE.
Understand. Dr.
Okay.
Yeah.
Yep. Ken. So thank you, Akasha, for the question. from my understanding of the question is basically, I think companies will always ask what is the cost of implementation and what is, of course, the ROI that is achievable through integration of these technologies, right? So from our perspective, when we look into cost of integration, we always look at the possibilities of, what is the cost breakdown, right? So a breakdown will always be hardware, software, and manpower, right? From our perspective, it's breakdown into these three component and framework, right? So if you want to, minimize cost, it needs to be looked upon in these three components, right? So hardware cost, I think, is more or less standardized, right? Let's say, for example, you want to get pepperl+fuchs IO-Link Master Hub. They have a standard pricing already and the sensors available, right? So the next part of it is software, right? It's either it's a concept of either you build or you buy, right? So of course, if you build it on your own, there is a lot of capabilities and a lot of platforms out there that are already available for you to explore, right? And therefore, you can manage your cost in that area as well. Now, the next area is manpower, right? Whether is it internal or external. So then you need to decide, if you are able to do it internally, which it is possible, I would say it is possible, having your own internal talents to be able to do it for you, right? And this also improves your overall, capabilities internally to be able to innovate something that is more unique for your factory automation, right? So therefore, when you look at these three components and you break down the cost, you can then be able to see which area can you actually optimize your cost savings, right? Which area can you optimize your cost savings, and how we at the Malaysian Smart Factory and SHRDC do it is basically we have designed programs that are able to help industries to build and integrate it on their own. So this is something that we do. It is something that you can explore, right? If you intend to. Of course, there are many other areas as well. So this is actually the three cost breakdown that I can share. And in terms of ROI, I think it depends a lot on how fast can you integrate this technology, right? And it starts from the first part, which is the leadership buy-in. That's a very important part, all the way to process understanding, right? Then all the way to the breakdown of what parameters you want to measure for OEE, then implementation, and then fine-tuning, right? So there's this process. So if you shorten the process, the faster your ROI. If your process is very long to develop something, then your ROI will also take very long process, right? So it really so the cost will depend a lot on your the three parts, which is the hardware, software, and manpower, and also your rapid prototyping, right, or deployment of your technology. So this will then be able to you will then be able to calculate better on what are your cost savings. So I hope that addressed your question. Maybe Gerard, you want to add on?
Yeah, absolutely. I think the key thing is not the, of course, how much cost is tied in with the budget. But as I mentioned earlier, the KPI is really matter. I think Dr. Chua covered most of the points over there. I think the implementation has a look into different factors. Not only cost, you have to look at safety, security, capacity. There's so much more you can bring to the business, and all these value adds to the business. So I think in terms of KPIs, it really is it's a holistic kind of view, and I agree wholeheartedly with what Dr. Chua said earlier. Yeah.
Thank you, Gerard.
Okay. Actually, mostly companies, factories in Malaysia, they don't have all three factors: hardware, software, and manpower. I think it's normal in factory in Malaysia. So they should have all of these things: hardware, software, and manpower. So maybe machine integrator maybe can have a package for them, because this is what they need. The industry in Malaysia need to implement the industry from zero. And then one more thing, yes, that's right, the KPI is very important, but the most challenge faced by them is the budget. So yeah, of course, they have a very high KPI. They want to achieve something, but the budget will restrict them to go further in industry from zero. That is my view. What happened in industry in Malaysia? I mean, not the big company, but the small company, which is mostly in Malaysia. Okay, thank you for both speakers.
Yeah. Thank you, Akasha. Maybe just to add on a little bit in terms of what you have shared. I think what you have shared is actually what we also hear from many companies, right? But from our side, we are a big advocate for people development and a people focused strategy. We are a great advocate for that because we see that Malaysia has abundance of talents, right? And it is always they are now a lot more of them are very technology savvy, right? And there's a lot of engineers and technical people out there that are able to then help the industries to scale up further. So these untapped talents can be considered by the smaller industries as well to look into these strategies. In fact, this is something that we are helping many industries to scope out, and we have seen great potential in that. So of course, it will take time, but we see this as a people-focused strategy as one of a key sustainable way when you want to talk about budget and cost, right? So it is something that we can definitely consider, right? And your company can also consider, and we are more than happy to talk to you about it if you're keen to explore. Yeah.
Thank you so much, Dr. Chua. I think there are some questions on the chat group, but let me get to Mr. Tan first. Mr. Tan.
Yeah, good morning. I'm Tan from CRBG Packaging. Because nowadays everyone is talking about the data collection, data storage, right? So once we talk about data, there is a concern about the data transmission. How fast, what is the speed? So up to what circumstance that we should consider either iCloud storage or in-house storage?
Perfect question. Dr. Chua.
Okay, thank you, Mr. Tan. Generally, when we speak to many industries, right, we always talk about, when we talk about data transmission and data storage, we always focus on what we call as on-premise first, right? On-premise first strategy will actually be able to help you to manage your data transmission more effectively, right? And data transmission or data transmission rate really depends on not the internet connection when it comes to factory, but it comes from intranet connection. So what I mean by intranet is basically, okay, let's say if your data transmission is being transferred at 1 gigabyte per second, okay, assuming 1 gigabyte per second, but your network switches are only up to a capacity of 100 megabyte per second. So basically, you are actually crowding an entire data through a small tunnel, right? So basically, it is a hardware dependence when you talk about intranet connectivity. So when we talk about data storage internally, nowadays, data storage servers, I don't think it's very expensive. Now, of course, if you want to make like a big server facility, that is something that you need to consider certain costs. But when we talk about edge devices, let's say you store 1 week's worth of data in an edge device or a PC, it doesn't take up a lot of space. The only time that it will take up a lot of space is if you are capturing like a lot of data in 1 second time. So if your data is being captured at 1 second, at one data point per second, and you have multiple ports, right? Therefore, of course, your data storage capacity needs to increase, right? Now, when we talk about cloud, right, it really depends on what you want to see in the cloud, right? Because if your machine control is dependent on your connection to the cloud, then there might be some latency considerations that you need to take note. So when we spoke to some factory owners, what was a concern was that when their whole entire dashboard is dependent on the cloud, when they lose connectivity, they lose everything, right? So that's why we always say on-premise first, then data to the cloud will be a subsidiary line or a parallel line so that you can still view your data in the cloud while you are still operating your system in the factory. Another thing is also to consider public or private cloud. So public cloud will be basically data servers that are hosted outside of the factory. Private cloud will be data servers hosted inside the factory. So this is something that you can also consider, right? To manage your operations and visibility.
Okay, thank you.
Thank you. So, but then again, Mr. Tan and Dr. Chua, then it opens another whole topic of cybersecurity and so on and so forth, which we should not get into this today. All right, Gerard, maybe you want to add on PNF side on data?
Sure. I think Dr. Chua again fabulously put it and packaged it. Just to sum it up, I think like for Mr. Tan over here, for hardware it's very important. I put in an analogy. It's like a highway, right? Like, so your hardware, if you're going from a small lane into a highway, your bottleneck will definitely be your small lane that you're coming from a single lane, for example. I'm just using a very broad analogy just in case. So it really is from your devices to your cables you use, whether it's fiber optic, for example, etc. And your switch, like Dr. Tan said, there's many switches out there that can accommodate that fast switching switches. And by the way, I just want to put in my company's name again. pepperl+fuchs has cables and switches. Yeah, sorry to squeeze in some advertisement, but yeah. So okay, so yes, so we have the so there is different switches and there are different cables that come to it. So and once you get the whole connection right, so you have all the connection right, like what Dr. Sun mentioned, the cloud is you have to consider like cybersecurity. Okay, I think you can Google the very recent hacking and it caused a whole factory to shut down worldwide. Is this very famous abattoir, Brazilian abattoir? I can Google. It's called JBS, right? So somebody hacked the factory. And the whole factory is using a ransomware. So basically, you don't pay the hackers X amount of dollars, they won't release the factory back to you. Right. So you can. It's a very classic example. So you have to be careful of security. Hence, like what Dr. Chua also mentioned, private or public cloud is very, very important. Intra or internet is also very, very important. Yeah. So if you have the expertise over there or you need to consult somebody to understand a little bit better, I'm sure there are expertise around Malaysia that can help you assist in that front. So once again, hardware first, and then after that, always on-premise is a preferred. There's intranet, okay, and there are many protocols for that. OPC is one classic example. And then if you want to go outside, want to go to the cloud system like public cloud, for example, then they have like things like MQTT protocol that comes into play. Yeah, that's our aligned view on it. Thank you.
Thank you, Gerard. Mr. Tan, I hope. Okay, fantastic. Alex, you have a question on the Smart Factory program, so I think I will touch on that later. There's a question here on the internet connection, and if in Malaysia, whether is it reliable enough? I think by Engku Ahmad Hilmi. Could you please elaborate what you mean by your question, please? Because that's very broad question. Is Engku around? Okay, so I think we just have to skip that question first. But I think it depends very much on what you want to use your internet for. Right? Then we have to decide later what do you really want. Then we have to speak to TMNet or time.com as well and see whether is it possible or not. You know? Generally speaking, so thanks, Gerard, for mentioning that. Now, we have a plethora of different kind of industries here. All right. So what is interesting is depending on where you're coming from. All right. I think the rubber industry via the Malaysian Rubber Council, you have some funds there which you can actually use to actually automate as well. So it depends on how you want to go about it. Then depending on the industry that you're coming from as well, sometimes they have these industry forward programs where I'm not sure whether this is still open, but I think, but I know that SHIDC via Dr. Chua, they're actually a mentor in that whole process as well at the same time. So if you require a bit more information about where to get government grants from, then maybe Dr. Chua is actually the right person to speak to. All right. Now, moving forward, sorry, before I go ahead with Alex's question, so would there be any other questions from the floor or from the screen? No question, yeah, I guess. So let me share my last, actually we have 2 more slides and after that we call it a day. Now, so with MSF Worldwide, what we have is for Alex, I hope it answers your question as well. So in the Smart Factory program, there are actually very different, programs, or rather training programs, let's put it this way, where you can actually consider. So these are one of the two that we actually recommend for people who want to start off beginning. All right. So there's a Smart Factory technical overview where actually the target is actually the MDs, the CEOs, and basically the C-level guys in the factory, so that you will know more or less what's going to happen, or what could take place as well eventually, in your factory. Then of course the one on your right hand here is actually data generation, where this is the beginning of how we actually start with. Remember earlier I mentioned about lighthouse projects. So this is where at the end of the day, where you can actually maybe consider taking 1 or 2 points in your whole big factory or your whole shop floor to actually start implementing a quick data generation course as well. So basically, in short, in this program, all right, the data generation, it is done, sorry, just to share a bit as well. So it is actually done remotely. So basically, in short, you can actually see how is it possible you can actually access their so-called shop floor in SHRDC remotely, and actually how to access their sensors. So in this case, it gives you a very good example of what an internet connection can be as well. All right. So, but it is also, of course, before you go ahead with the course, we normally suggest as well, within your factory, maybe you can look at, okay, what is it that I need to actually automate as well? How do we get this maybe a legacy machine that you have that you actually want to actually bring it forward as well, and how do we automate them, and how do we get them to talk to each other? So from there, then you can actually use that as an example to actually use to go with the data generation course that they have. All right. I hope that answers your question, Alex. Otherwise, I think you can contact either Dr. Chua or myself as well, and we can proceed from there. All right. I hope it answers your question, Alex. All right. So, without further ado, thank you very much again for all the gentlemen here and there, for ladies and gentlemen, for joining us. So we have a YouTube channel where we actually put in all our webinars inside there. So if you can scan it using a QR code, you can actually do it online as well. Or if you want to subscribe, you can actually subscribe as well to actually see what's new. Before we leave, I would like to invite Dr. Chua and of course Gerard later to actually share a few words of wisdom, or maybe some parting words. Dr. Chua.
Okay. Thank you very much, Kenneth. And thank you, Gerard, for a great presentation. So just before we leave, I would say that getting machines to talk to you is not very difficult, right? It actually requires you to take the first step of understanding how machines communicate with each other. Right. Once you understand how it communicates with each other, what are the sensors available to tap, and what are the possibilities that you can use to actually get those information, I would say that it's very, very possible for you to get started. Right. And we always advise many industries to start with a lighthouse project. Right. Pick one machine, just one machine, pick one machine, get the data from it. It can be through various methods, like what I shared with you just now. Right. And start that data work for you, right? And once you start to see the value of it, deploying it and replicating it is not very difficult, right? Because once you have that kind of ownership of the platforms, it's very, very straightforward for you to integrate further. For us at the Malaysian Smart Factory at SHRDC, we are more than happy to speak to you about any of the ideas or questions or budding concepts that you have in mind, with regards to your factory operations. We are more than happy to help you. And in terms of this current lockdown period, I think this is actually the best time for us to sit down together and review virtually what are the problems that you have, which I do share with the industries that they can share with me virtually, their current factory problems. And we are more than happy to help you move forward. Yeah, together with the team at MSF Worldwide. So just get in touch with any one of us. We are more than happy to help you.
Thank you so much, Dr. Chua. Gerard.
Yes, thank you, everybody. Thanks for attending the seminar. If there are any other further questions for us, you'll be happy to take them. I would like to sum it up by saying that take the leap of faith. You never know what happens. I think that's a key thing. And just to share interesting story is that my mom doesn't know. My mom is like 70 plus years old, and she can now use automated payment. So the next time, next time you're in Singapore, by the way, a lot of our hawkers are going towards automated payment. Soon you have to not use cash, but like use I don't know, an e-wallet to start paying for that. So if the hawkers can do it, I'm sure you can too. Thank you very much.
Nice. So soon will be something like China that everybody takes a WeChat Pay. No?
Yes, absolutely, yes.
Fantastic. So thank you very much. So just out of just to leave off, just to leave maybe a quote. All right. So I read one day about Mark Twain. If you know Mark Twain, very interesting. So he says that 20 years from now, you will be more disappointed by the things that you didn't do than by the ones you did do. So throw off the bowline, sail away from safe harbor, catch the trade winds in your sails, explore, dream, discover. Right. So I think very much is let's. I know it's difficult. It's never easy, starting on a new to start off. But you never know if you take that first step. Right. Thank you very much again, very much, ladies and gentlemen. Before we leave, I hope I can take a nice photo of everybody. So if possible, if you switch on your videos, please. Everybody is off video. I would say got some videos coming out. We need a bit more. Okay, cool. So just thumbs up, everybody, and give a smile, please. Thank you. All right, cheers. So thank you very much again, gentlemen. We shall update you all once the YouTube video is up, and then you can continue to refer to that as well. Yeah. So Gerard's contacts are there, Dr. Chua's contacts are there as well, and of course, including us. Thank you very much, ladies and gentlemen.